So here is another MyMathLab example. Again, some of you may get this exact one. Others of you may have some of these numbers changed. But I wanted to do this one because it looks a little bit different than what you're used to seeing. So it's already factored for us. It's actually making you walk through the process of finding x-intercepts, y-intercepts, and so on. So I'm going to go through the whole thing. I may have to do this in 2 or 3 videos because I don't like having them be too long, but we'll get the whole thing in. Okay, so it says, summarize the pertinent information obtained by applying the graphing strategy and sketch the graph of this function. So the first question says, select the correct choice below, and if necessary, fill in the answer box. So the first question is talking about domain. So if you remember when we were going over first derivative, I said you always want to find the domain first. So this is where domain is going to come into play. This is just a polynomial, right? It's a factored polynomial, but it's just a polynomial. That's all it is. So anytime you have a polynomial, your domain is always negative infinity to positive infinity every single time. There's no restrictions to it. There's no fraction, there's no radical, and there's no logs. So if you don't have any of those and it's just a straight polynomial, your domain will always be negative infinity to positive infinity. All right, the next one says the x-intercepts. So you're looking for x-intercepts. So remember, we haven't done anything with first or second derivative. It hasn't asked you where is it increasing or decreasing or where is the concavity. It's just asking you based on your function, what are the x-intercepts. So remember, when you're looking for an x-intercept, the x-intercept is when y is 0, right? So if you think about a graph, x-intercepts, these are my x-axis here. X-intercepts is when my graph crosses the x-axis. So the only time it's going to cross the x-axis is when my y value is 0. So what I have to do is I have to come back to my function and go, okay, when is my y value 0? Well, I'm going to change this because f of x just means y. I'm going to take out my y and plug in 0. Well, you know how to solve this. This is just setting your function to 0 and solving. So the only way for this times this to be 0 is if x minus 5 equals 0 and if x squared minus 10x minus 50 equals 0. So you have 2 factors that you're just going to solve for x. So again, x minus 5 equals 0. I'm going to add 5 to both sides, so I get x equals 5. That's one of your answers. The other answer is x squared minus 10x minus 50 equals 0. So now you can factor, or remember, if you don't like factoring, or if factoring is not easy for you, you can go right to quadratic formula. Well, in this case, you can't factor it. There is nothing that I can multiply to get negative 50 and add to get negative 10. There's no factors that do that. So don't waste a lot of time trying to find the factors thinking it's always going to be factoring. Excuse me. Just go right to the quadratic formula. So I'm going to run out of room. So the quadratic formula, again, is negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. That's the quadratic formula. So where do these values come from? This value right here is a, which is a 1. This value right here is b, and this value right here is c. There are no x's in my quadratic formula. It's only the coefficients, the a, b, and the c. All right, so here we go. I'm going to just plug my values in here just to save room. So my b value is negative 10. Notice I put parentheses around it. If you plug this negative 10 into your calculator without parentheses, it's going to give you an answer of negative 100. This first value right here will always be a positive because it's whatever that value is squared, negative 10 times negative 10, which is a positive 100. So my a is 1. My c is negative 50. And then down here, my a is 1 again. Okay, so now you're just simplifying this. You work underneath the radical first. So I have positive 10 plus or minus, negative 10 squared is 100. Negative 4 times negative 50 is 200. It's a positive 200. So I have 100 plus 200. So I have the square root of 300 all over 2. Okay, now this is something that you probably haven't done in a really long time, is just simplifying. In my math lab, they're just simplifying this. They don't want like a specific answer as far as like 4.3 or 7.99. They want you just to simplify this. So real quick, what you're going to do is you're going to take what's under the radical and you're going to break it up. So I'm going to do this over here. I'm going to break this up so that I have two factors. One of the factors is a perfect square. So 300 can be broken up into 3 times 100. 100 is a perfect square. So the reason why I do that is because, let me rewrite it for you. Now I can simplify this. So I can't take the square root of 3. It's a decimal. I don't want that. But I can take the square root of 100. The square root of 100 is 10. So this gets written out as 10 plus or minus 10 square root of 3 all over 2. Now, notice the square root of 3 stays under, or the 3 stays under the square root sign. The only thing that gets pulled out is the square root of 100. So that gets pulled out as a perfect square. And now I can simplify. So 10 divided by 2 is 5, plus or minus 10 divided by 2 again is 5, square root of 3. So notice I have two answers here. I have 5 plus 5 square root of 3, and I have 5 minus 5 square root of 3. So if you aren't sure about simplifying radicals, you can go back and look on YouTube. Just type in simplifying radicals, and it'll walk you through this process. The idea is whatever number is underneath, find two factors where one of them is a perfect square. And then you can square root that, and then you can simplify. So in my math lab, this is going to be your answers. You have 5 plus 5 square root of 3, and you have 5 minus 5 square root of 3. These are my x-intercepts. That's where my graph is going to cross my x-axis.